All right, so what else can we do with the equations to make our life simpler, right? So when we work with fractions, here I got an equation that's got a bunch of fractions in it. I know we don't like them, but we know in composition that canceling is a huge part and we want to take advantage of it, these fractional factors of 1. Now, before I show clearing fractions, I want you, I want you to note that we can solve without, we can solve this equation 1/2 x minus 2/3 equals 1/4. We can do this by, if we knew how to do fractions really well, right? Or if we had a calculator, we could do this really well, easily. Calculator does fractions. But we could just solve this by realizing to get x by itself, we'll get rid of this first term, we'll isolate the variable term. That means I need to add 2/3 to both sides. The left side would be 1/2 x. And if we take 1/4 plus 2/3, we're going to get 11/12. And then to get x by itself, we just need to cancel this extra factor of 1/2. We'll just multiply by 2 to cancel. So multiplying both sides by 2, we'll get x on the left, and then 2 goes into 12 6 times. This would be 11/6. So if we could work with fractions, this is really a pretty basic problem to solve. But I want us to get some practice with what we call clearing fractions. So when we look at our expressions with these fractions, I want us to think, what could I multiply by on each side, each expression? What could I multiply by that would cancel every number? So think about what factor, or what can you multiply by, what would cancel with every denominator. So if you notice, if you multiply by 2, well, that would cancel this one, but a 2 would not cancel the 3. So what number would cancel every denominator that we see here? I need to be able to cancel a 2, a 3, and a 4. And if we think of 12, right? 12 will cancel with the 2. It has a factor of 2 in 12. It also has a factor of 3 and a factor of 4. So a 12 will cancel every denominator. As long as I multiply both sides by 12, the equation is balanced. So here's what it would look like. In the first side on the left, I have 2 terms. So I know I need to distribute 12 in order to multiply that whole side. So I have a factor of 12. And I'm multiplying it by the 1/2. Whoops, I'll do that in black. The 1/2 x. The second term, I have a factor of 12. Whoops. And I'm going to multiply that by the negative 2/3, right? This factor, or multiply it by this negative 2/3. And on the right side, I got the 1/4, and I'm going to multiply that by a factor of 12. So I wrote all this down so I can keep looking at each term and so on, and then manipulate. But what I'm saying is 12 will cancel when I multiply with every one of these denominators. So the 2 in the denominator will cancel with the 12, and it leaves a 6. So this term is really just 6 times x. This term would become 6x. The second term, 12 times negative 2/3. Well, the 3 in the denominator will cancel with the 12, and it leaves a factor of 4. So this term is 4, and then times negative 2. So this term would be just negative 8. And then that's equal to, well, the 1/4 and the 12, the 4 in the denominator cancels with the 12, leaving a 3. And the right side would just be equal to 3. So you notice, right, the fractions are cleared. They're gone. No, we didn't solve anything, but we end up with expressions that do not have fractions in them. So now we can just continue to solve here, right? So we'll isolate the variable term on one side. We'll attach an 8 to both sides. We'll get 6x equals 11. And then isolate the variable factor. We'll cancel this factor of 6. And we get x equals 11 over 6. So clearing fractions is a way to simplify an expression. So notice this is part of simplifying our expressions. So it's one of the first things we do. So I just want to take and look at this next one and realize when we are multiplying that the canceling is important, but what's really important are the factors that are left when we cancel. So I'm going to show you how to do this so it doesn't take up so much space and so much writing. I need to write this up a little bit higher so we can manipulate this. But let's clear fractions here. And again, I have expressions in my equations, so I'm going to clear fractions. So what number will cancel? Think of your goal. When you clear fractions, the goal is so every denominator cancels. Again, I want to think about manipulating expressions. Well, you've probably heard this before, but the lowest common denominator actually does that. If I look at 3, 15, and 5, the lowest common denominator is 15. If I multiply both sides of this equation by 15, when I multiply it to the fractions, the 15 will cancel with the 3, the 15 will cancel with the 15, and the 5 will cancel with the 15. So how can we do this? So that we can keep track of everything. So I'm going to write this one out, term by term. I know I need to distribute the 15 to both of these terms. So I got the 15 times 2/3 x. I'm just going to pause the video and fill the rest of this in. All right, so what I've done is just on each of the terms, I just distributed the 15 to each term. So the terms on the right, I distributed 13 over 15x times 15 and so on. So now I'm going to go back through and start canceling, start multiplying these through. So again, the 3 in the denominator will cancel with the 15, leaving a factor of 5. This term would give me then a 5 times 2x, which is 10x. If you notice, I do have to distribute to the -2 because I want to make sure the 15 is multiplied to the whole side. And that's why I'm using the parentheses to make sure I don't miss that. So even though it's not a fraction, I still need to multiply. So 15 times -2 would give me a term value of -30. Well, that's equal to, when I take the 13 over 15x times 15, well, the 15s will cancel, and that leaves just 13x. And then the last term, the 5 in the denominator will cancel with the 15, leaving a factor of 3. So 2 times 3 is 6. So our fractions are cleared, and now we can start solving. So maybe this one, isolate the variable term. I'll attach a negative 10x to both sides. That would give me a 3x on the right. So that means to isolate the 3x, I want to get rid of this positive 6. So I'll attach a negative 6 to zero that out. And I get, on the left side, negative 36. And then finally, isolating the variable factor, it looks like I get negative 36 over 3, or negative 36 divided by 3 is negative 12 equals just x. So the next example I'm going to go through, I'm going to kind of shorten this up, but I'm going to save that for the next video.